We'll try again. All right, so this has got it all, right? Let's go through all the information that they've given us. The tangent of theta is negative 5/4. Right? So what do we know? Since the tangent value of the angle is negative, that has to occur in quadrant 2 or in quadrant 4 where our tangent values are negative. Right? The output of the tangent is negative. Based on that, and you can't look at this, let's take one step further. Let's go back one step further. You can't say, oh, well, that's the y value and that's the x value, because they're not telling you that this is an angle that's on the unit circle. Right? So you can't say, well, that's y, that's x. So the cosecant is 1 over y, and then just spit out the answer. It's not that simple. All right? If we say that the tangent of theta is negative 5/4 in quadrant 2 or in quadrant 4, and then it's saying this, the cosine value of the angle is greater than 0, meaning it's what? It's positive. So the tangent value is negative. The cosine value is positive. So we've broken it down. We've narrowed into that one area. What quadrant are we in? Where are the cosine values positive?
4.
Quadrant 4, because the x values are positive in quadrant 4 from the unit circle. That's what the unit circle gives us. It gives us the blueprint, and it says, well, since the x coordinates are positive in quadrants 1 and 4, cosine values are positive in quadrants 1 and 4. Right? So we've got a negative tangent value in quadrants 2 and 4. We've got positive cosine value in 1 and 4. The only thing they have in common, this angle is in quadrant 4. So let's start with that. Down here somewhere, I have this angle. I don't know what it is, okay? I'm going to call this theta. Now we can go 100 different ways with this problem. But I'm going to go the route of using these Pythagorean identities that we just talked about. I know the value of the tangent of theta. Now, one and only one of these Pythagorean identities includes tangent, right? But if I was finding all 6, you have to put yourself in this frame of mind too. If I was finding all 6 trig functions and not just cosecant, I would already know a second trig value. What else do I know? Cotangent. What's cotangent?
Maybe 4 over 5.
Yeah, flip it over. So I also know that the cotangent is negative 4 over 5. Now I've, for lack of a better word, I've unlocked another identity, because now I know a cotangent value. So go back to this. So I could use this if I wanted to find secant, or I could use this, because I know this now, to find cosecant, which that's what they're asking me to do, find the cosecant of theta. That's what these Pythagorean identities are useful for. Right? I've identified I'm in quadrant 4. So in the end, as a check, let's get this out of the way, what does my answer have to be?
Positive.
Positive or negative? We have one person saying positive, we have one person saying negative. Cosecant is related to what? Sine. And we're in quadrant 4.
Negative.
Where sine values are negative. So we know our answer is going to have to be negative, right? More to follow on that. Here's what I know. Okay, you have your choice. Which one of these do you want to use? Option A or option B?
B.
Option B, because I've got cotangent, it's going to help me find cosecant. So we start to work. 1 plus, right? Let's write this down just so we have that reference, so I don't have to keep flipping back and forth. So I've got cotangent squared here, cosecant squared there. Remember that this is really, oops, sorry. Ah! No, I'm okay. Is really this, right? Do the same thing over here. You're never going to see me write that ever again, but because I'm on video and because I want people to have this forever, that's really what we're talking about. And I know what cotangent theta is, so it's a simple substitution. I'm not putting the negative 4/5 in for theta. I know what cotangent theta is. I'm putting this here. So now I'm going to switch it up. I've got 1 plus negative 4/5 squared equals cosecant theta squared. we do the math. 1 plus, when I square this fraction, negative 4/5 times negative 4/5 is positive 16 over 25, which is equal to the cosecant of theta squared, right? Leave it like that now if you want. That's fine with me, I guess. Oops. I can add these. I know that's not a fraction, but I can make it a fraction. I can call that 25 over 25 because it's got a common denominator here. So we end up with 41 over 25 equals cosecant of theta squared. So we take the square root to get cosecant. And because we're honors students, we know taking the square root of fraction, same thing as taking the square root of the top and the bottom. So we have the square root of 41 over the square root of 25. And we're honors students, so we recognize the fact that when we take the square root of values, we have to account for both positives and negatives. And I know we've already set we've set the table for we're only accepting the negative value, but never a bad idea to continue with that, to have that consistency. So this is equal to cosecant theta. Square root of 41, prime number, so whatever. Square root of 25 is 5, and now we recognize that we need the negative from this. So this is our final answer. Cosecant of theta is negative radical 41 over 5. Okay, and for lack of a better description of the y, before when we started this problem I said it's not just y over x. It's only y over x if we recognize these values from the unit circle. These are not values that we're comfortable with that we've seen in the unit circle, right? So you can't go into a problem just assuming that the tangent value is always the y value over the x value, because if you did that, then you'd say, well, cosecant, that's 1 over y, so this would just be negative 1/5. Because if y is negative 5, then this would be negative 1 over 5, or 1 over negative 5. But obviously, through our work, we recognize that's not true. So again, this concept of, going back to it, tangent is y over x, only if we are on the unit circle. Okay, we only get to use that sort of concept. You got to understand when to use when to use right triangle trig, when to use unit circle trig. However, the Pythagorean identities are universal. They'll always work with the ratios from right triangles or with the ratios that we have from the unit circle. Okay? End scene.